So this is what the XY coordinate plane, and other than the rectangular coordinate plane, the XY axis, does anyone know what else it's called? What is the correct name for this? Begins with a C. Anyone? You guys talk? No one can tell me?
Coordinate plane?
No, but that's also another name for it, yes. Anyone else want to try? So it's also called a Cartesian plane. The Cartesian plane. Okay. Now, why do we need this? So you will see that we have, and you have seen this already many times. This side is all positive, 1, 2, 3, 4, dot, dot. This side is all positive, 1, 2, and then this side is negative. And then the bottom is negative again, okay? So it's really where we can find, for example, you've looked at slope of a line. For example, if I have 2 points, let's say I have this point here, let's call that point A. And let's say I have a point over here, point B. So you should be able to tell me, okay, where is point A? Suppose I ask Jennifer that question. Suppose I say I'm at point A. Where am I, Jennifer?
Coordinate 1. I mean quadrant 1, sorry.
I'm in quadrant 1, very good. Can you be a little bit more specific?
2, 1.
2, 1, very good, very good. This is the point 2, 1. The first number always read off the x-axis, okay? And the second number always read off the y. So you're 2 on the x and 1 on the y, okay? Sharna, where am I in point B? Or let's say you're at point B, Sharna. Where are you?
I'm at -3, -2.
Excellent. -3, comma, -2. Excellent. This is x and that's y. Okay? So you guys have to know what points or how to plot points. So how about if I give you this point here, let's call that point C. If that's point C, and I ask Crystal, where am I? What would you tell me, Crystal?
I would say I'm at at 4, 0.
4, 0, yes. You must, anytime you give a location, okay, location must be, sorry, 2 sets of coordinates. So it's 4 on the x, 0 on the y. Now this point here is a special point. Okay? Does anyone know why I say it's special?
Because it's on the x-axis?
Very good. This is an x-intercept. Any point that's located on the x-axis is called an x-intercept. A little note, you will notice that for x-intercept, guys, the y value will always be 0. Okay? Likewise, if I label this point here, okay? Angie, where is this point? Let's call that point D. So this was point C. Let's call this point D. Where is point D, Angie? Can't hear you.
At 0, -2.
X is 0, y is -2. And similarly, this point here is what we call a y-intercept. And you will notice, you will notice for y-intercept, the x value is always 0. So with that being said, if I give you a point, okay, so let's try this. Try this. What can you tell me? What can you tell me about the points? Question A, 5, 3. Question B, 0, 7. So what can you tell me about 5, 3? Come on, if I'm doing class, I really don't want to be calling on names every minute for an answer. Can we like talk?
It's in the quadrant 1.
Okay, can you say your name for me when you talk? So at least I know who am I talking to.
This is Sharna.
Sharna, good. So 5, 3 is in?
Quadrant 1.
Good, very good. So this is, it is located in Q1, we write, okay? Quadrant 1. Anything else you can tell me about 5, 3? Anything else you can tell me about 5, 3?
It's an all positive value, so that's why it's in quadrant 1.
Right, you can add to that. You can say since both x and y is positive, it's in quadrant 1. Yes, you can do that. Okay. How about B? What can you tell me about point
Sharon?
B?
Sorry.
What's that?
I was just saying my name so I can.
Okay.
Okay, so that one will be on quadrant 2.
In
Since
quadrant 2?
I mean, sorry, quadrant 1, right?
I don't know.
Wait, sorry. Can we?
Look
That
what
one's in between because it's on the y-axis, right? On the x-axis.
Sharna, right?
Yeah.
Sharon was talking, right? So Sharon, suppose
I'm sorry?
now later today.
Yeah, Sharon. Yeah, it's because I just got a little.
You're breaking up, Sharon. Yeah, dropped.
Yeah, sorry. My Wi-Fi is not that great, so sometimes it just shuts off.
You have Sprint, don't you? No, I'm just kidding.
I really do. That's the funny thing.
Okay, so if you notice here on this point here, this is x and this is y, right? X is 0. Anytime x is 0, what can you tell me? Let's go back to the notes. Anytime x is 0, what? It's what?
A y-intercept?
Yes, this is a y-intercept. It is a y-intercept. Hence, Sharon, if you can hear me,
Yeah, I can
intercepts
hear you.
are never in a quadrant. Right? Suppose now later this evening you have to meet one of your friend or a bunch of friends on the Brooklyn Bridge. Which borough do you live in, Sharon?
I live in Manhattan.
Okay, good. If you have to meet someone on the Brooklyn Bridge or the Manhattan Bridge, doesn't matter. And when you went home, you have to tell whoever you're living with, mom, dad, brother, sister, whoever, and they ask you, which borough did you went to? What would you say?
I'll just say I went to the Brooklyn Bridge because it's right in between.
Right, you did any borough.
Mm-hmm.
Okay, you went on the bridge, you went right between, so you're not in a borough. Okay, now politically speaking, I just want to make this clear to you. Politically speaking, now not math, which borough is the Brooklyn Bridge in? This is
downtown
common.
Manhattan.
What?
It connects downtown
Wait.
Manhattan, yeah, and Brooklyn,
It, the-
but it's technically in Brooklyn.
it's the Brooklyn Bridge. Brooklyn
Mhm.
responsible for all repairs in that bridge. It comes out of their budget. Get it? Brooklyn Bridge. Okay? Comes out of their budget. So be careful. You know, sometimes we do things mathematically, but realistically, it's not what we want it to be. Now, what else do we need to know? Well, on the XY axis, and this is something that you will have to review by. So everything that I'm doing here is all review, okay? Everything I'm doing here is review. So if I have 2 points, let's call this point A, 1, 2, 3, 1, 2. So let's say this is minus 3, 2. And let's say we have a point B here, 1, 2, 3, 4. I'm going to change that point. Let's say it's here. 1, 2, 3, 4, 3. Let's say this is point B. And if I now connect a line from A to B, okay? This is a line. Please pay attention because the way we speak can be very misleading. This is a line connecting point A to point B. Is that correct?
Yeah.
Yes.
Okay, the answer is yes, that is correct. Listen to this now. This is a line passing through point A and point B. Is that correct?
No.
No, it's not a line passing through. For it to pass through, I had to extend it and put arrows. You see the difference? So sometimes when you read, you have to be careful. Now, what can you tell me about this line connected A and B? What can you tell me? Guys, what can you tell me about the line connecting A and B?
It's going through the origin. Well, not, yeah, through the origin.
No, it didn't. Come on,
Two
look, look,
endpoints.
look, look,
Oh,
look, look,
it's not.
look, it's not. Right? Good.
It's connecting two quadrants. Quadrant
It's
1 and quadrant
Has
3.
two
okay.
endpoints.
There are 2 endpoints. Good. So you see, there's a lot of things you can tell, right? Like you guys can all see me. If someone asks you later on today, let's say after this class, right? Someone in your household say, what can you tell about Professor Jagai? You can probably list a bunch of things, right? He wears glasses, he's not bald, he looks fat. I don't know. I don't know what you're going to say. Maybe you're going to say he's nice, he's ugly. I don't know, right? What can you tell me about the line connecting A to B? So yes, everything that you've said is correct so far. I'm looking for something special here.
It's a hypotenuse.
No, you don't know that. Hypotenuse is only when we form a triangle. I know exactly what you're thinking because you're thinking of that triangle here. M. Do you guys know what M stands for?
Oh, slope.
Slope. Yes,
Slope.
stands for
Line
slope.
of-
M is the nickname for slope. Like for example, Mr. Manny, your nickname is Yo, right? Someone see in the street, they don't know you. Let's say you drop something, right? What does New Yorkers say? Yo, you dropped something. Or excuse me, you know? We got a lot of names in New York. So M is the slope. By looking at a line, class, you should be able to tell me the slope. Okay? A line can only have 4 different answers for slope. So what can you tell me about the slope of this line from A to B? Anyone?
A positive slope.
It's a positive slope. Why do you say that?
Because
Who's speaking? Jennifer? Okay,
yeah.
go ahead.
Because it's going, I don't know, just the way, like, I don't know the mathematical, like, I don't know.
Okay, I just started the video. Do you guys see anything on your screen?
No.
No. Sometime
Yeah.
okay, it's rolling now again. So anytime the denominator is 0, right, the slope will always be undefined, always. And that will happen anytime the x values are the same. Okay. So the xy coordinate, by looking at points, you can tell the slope. You guys should also know about the distance formula. Distance, usually called d, and that is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So if you know that formula, right, now if I gave you 2 points, you should be able to tell me, let's say this point here is minus 5, 4, negative 4. Let's say this is point A, and let's say this point B here is 3, 1. You can be able to find the distance of the line connecting A and B, right? Because for every point, you know this is X, this is Y, this is X, that's Y. So you should be able to plug those points into the formula and find distance. So all of this is review, okay? You should also know what is called the midpoint formula. The midpoint. Okay, the midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And the midpoint would be somewhere over here. I don't know if I had to guess. It's the middle of the line. It's the location of the middle of the line. Questions?
No.
Mhm.
I'm paying attention to the lesson. I'm so sorry.
Guys, I need your help with that, okay? Throughout the semester if we meet. So let's say we have 3 vertices of a triangle. A, B, and I don't know, C. Right? So what I'm gonna do now, I'm gonna draw a triangle. Let's make our triangle green. Okay, that's a triangle. Does everyone agree with that? And
Yeah.
assume each one of this is 1 unit, okay? So you actually know the coordinates of A, B, and C, right? So 1, 2, 3, 4, for example, this is gonna be 4, negative 1. This is gonna be negative 1, 2. And this is going to be negative 2, 2, negative 2. Now, let's see how many of you are really thinking, and let's see how many of you is what we call street sense smart. You were able to tell me, by looking at this triangle, is this a right angle triangle? Yes or no?
No.
No. Why do you say so, Sharon, right?
Yeah.
Why do you
Because it
say?
doesn't have a 90-degree.
Very good. So that's the first thing, right?
That's an equilateral.
Your instinct will tell you, okay, that this is not a right angle triangle, because if it was a right angle triangle, you would expect to see a 90-degree angle, either there, or if you didn't like, oops, if you didn't like it there, here, oh, come on, or here, but not 2 of them. It has to be one or the other, right? Now, I left that out willfully. My question to you, how can you justify that this is or is not a right angle triangle?
Using the distance formula.
Okay, that's a start. Who spoke?
Crystal.
Crystal. Okay. You could start out by using the distance formula, because by using the distance formula, right, we can use the distance formula to help, right? You can find the distance between B and C, because you know the point B is the point -1, 2, and the point C is 4, -1. And the distance formula is x2 minus x1 squared plus y2, not y squared, y2 minus y1 squared. So D is equal to the square root of, let's call this x1, y1, x2, y2. So x2 is going to be 4 minus x1 will be a -1 squared. Y2 is a -1, and minus y1, which is 2 squared. So D is equal to 5 squared plus -3 squared. So D is equal to the square root of 25 plus 9. D is equal to the square root of 35. You agree? What does that tell me?
Yes, you got to change it. You put 27.
Yeah.
Oh, thank you. Thanks. So that's 30. What did I do? Where did I get 35 from?
That'd be 34.
34. Okay. So all that tells me is that this here is the square root of 34. Can you do similarly and find this side and that side for me, if you had to do it? Can you take a minute and do those two sides for me, please? I'm going to pause the video. Take a minute and try them quickly. 2 minutes.
You're recorded.
I just started.
It was on my screen recording the whole time.
Really?
Yeah.
Oh. All right, let's do that quickly over here, right? So it'll be the square root of x2 minus x1. So it'll be 4 minus a -2 squared plus y2, which is -1, minus y1, which is a -2 squared. So this becomes the square root of 4 plus 2 is 6 squared, plus this becomes -1 plus 2, which is 1 squared. So this is 36 plus 1 is 37. So this here is supposed to be 37, the square root of 37, guys. Somebody had said that before, I think, right?
Yeah, I did.
You gotta be careful with the signs, okay? Now, pay attention. Pay attention, please. You just found 3 sides. One, actually, I don't want to use green because the triangle was in green. Let's use this one. 1, 2, 3. Of those 3 sides, which one is the largest side? Come on, guys. Of this 34 and 37, which is the largest?
37.
37. Okay. 37. So we can now use a squared plus b squared equals c squared. So c squared is always the longest side. So this will be the square root of 37 squared. And it doesn't matter which one of these two now you use as a and b, but this side has to be c because it's the longest. So we can say the square root of 34 squared plus the square root of, what was it, 17? 17 squared. So the square root of 34 is 34 squared. The square root of 17 squared is 17. And this will be equal to 37. Is there any way when you add this, it is equal to that?
No.
No. Because if you add 17 and 34, 7 and 4 is 11, 3 and 1, 4 is 51. 51 does not equal to 37. So this is not a right angle triangle. Okay? That's how you justify it. You couldn't justify it by looks, guys. You cannot tell by looking at it because sometimes things are not drawn to scale. So you cannot tell by looks. Any questions? Questions?
No.
Okay. So although we were talking about slope and about distance of sides and so on, do you see how you can use it in an application problem now? Right? You can actually use it in applications if you know the length of things to say if it's right angle or not. Okay. Okay. So some of the things, the first thing that you know of equation and graphs. Okay. Y equal mx plus b. This is linear. Okay. And the graph of a linear equation is basically a straight line. This is y equal mx plus b. Now, for an example here, y is equal to 3x plus 4. Okay? Now, you guys can all see me?
Yes.
Okay? Everyone can see me, right? Let me take off. Anytime the exponent of the variables is 1, that equation is linear. If it's not 1, it is not linear. Okay? So this is linear, guys, linear. How about if I ask you this example? Example, 3x plus 4y equals 12. Is this linear or not linear? Linear or not linear?
Not linear.
Who spoke?
Sharon.
Sharon, what's the exponent of the x?
I'm sorry, can you ask it again?
What is the exponent of the variable x?
Oh, 3.
Sharon,
Yeah.
please listen to my question.
I'm sorry.
Here, Sharon, let me help you.
Yeah.
This thing here is called a coefficient.
Yeah,
That's
right.
the exponent, right?
Mm-hmm.
The exponent would be this thing up here. What number is there?
1.
When you don't see a number, it's understood to be
1.
1.
Mm-hmm.
Okay?
Yeah.
So there's 1 here, and there's a 1 there. Do you see any other letter in this
Y.
equation? Y. What's the exponent of the y?
1.
1. Do you see any other letter in this equation?
No.
No. Are all the exponent of each letter 1?
Yes.
Yes. Then this is linear.
Got it.
Okay?
Mm-hmm.
So, question, the big question here, is this a linear equation? And there are 2 ways you can answer. Answer number 1, yes, because the exponent of each variable is 1. And now alternatively, or answer number 2, you can say this equation can be written in the form y equal mx plus b. Meaning, what does this mean? What does this mean? This means you can take 3x plus 4 y equals 12. You can subtract 3x on both sides. You get 4y is minus 3x plus 12. And then you divide every term by 4. Onto my pen. So y is equal to minus 3 over 4x plus 3. This is linear. Okay? Any questions?
No.
Questions? Okay, so those are the only 2 answers you can give for linear, guys. Okay? Those are the only 2 things you can tell. Then we have nonlinear. Nonlinear. For nonlinear, the list is very, very long. Okay? We have quadratics, which is a member of nonlinear. Ax squared plus bx plus c equals 0. This is a quadratic equation. Okay? I'm not going to write the equation part of it, just equation. We have cubics. Mean we can write ax cubed plus bx squared plus cx plus d. We have roots, radicals. The square root of a. I'm just using letters, we'll see. And this list goes on and on and on. We have rationals, etc. Okay. So, example, y is equal to x squared plus 7x plus 12. This is quadratic. Okay. If you draw this, you should know the graph of any quadratic is called a parabola. Okay. And a parabola looks like this. Or it could look like this. If the coefficient here is positive, then it would look like this. When it's negative, it will look like this. So A is greater than 0, it would look like this. If A is less than 0, it would look like that. Okay? So there's something unique about the parabola. So let's look at the parabola. Let's look at the parabola. Okay. You guys are not talking when I talk to you. Who did I ask? So when you got up this morning, if you looked in the mirror, what did you see, Crystal?
A blemish,
A what?
a new blemish, a pimple, a new pimple.
Okay. But basically, what did you see before you even observed that pimple?
My face.
You see yourself, right? You saw a reflection, right? When
Yes.
you get in the mirror, you see yourself, right? If you don't see yourself, you better run. You basically see yourself.
Yes.
Okay, good. So let's say this is a parabola. Okay. This is some parabola. Okay. Now you will notice that this side of the parabola, let's see, this side of the parabola looks the same as this side of the parabola, doesn't it?
Yes.
Okay. And when that happens, we say that a parabola has symmetry. Symmetry means reflection. So which axis does it reflect in?
The
Axis is acting as the mirror, the y-axis. Do you follow?
Yes.
So when we talk about symmetry, we're talking of reflection in an axis or a line. For this course, we only look at 3 types of symmetry: x-axis symmetry, y-axis symmetry, and what we call origin symmetry. Okay? So if you look at this graph, okay? If you look at this graph here, this graph is the graph x cubed. This graph has what is called origin symmetry, because once again, if we look at this side of the graph, okay, it looks very similar to this side of the graph. So this point here, let me do that with a different color. This point here, let's say that's the point 2, let's say 1, 1, and I'll make it up. 1, 1. This point here will be, for symmetry, -1, -1. Okay. So you'll notice that it's sort of a reflection along that line, in the line passing through the origin. So this line here is sort of the mirror. Do you follow?
Yes.
So there's only 3 types of symmetry. We're going to talk about y-axis symmetry, origin symmetry, and then we also have graph that looks like this one here. And this graph that I'm going to draw is called a hyperbola. A hyperbola. It's sort of like a sideways looking parabola. You will notice for this graph, this side here, okay, looks very similar to this side here. And now this is reflected on the x-axis. So this one has x-axis symmetry. This one had origin symmetry. So I'm about to close off, so I'm just going to tell you verbally, how do you check for symmetry? The idea of checking for symmetry, guys, please listen carefully, is that if you take an equation, okay, check for symmetry. If you take an equation and you replace, let's say for y-axis symmetry, so let's say this is the point 3, 5, and you reflect this point along the y-axis, that point will be somewhere over here. Do you agree with that?
Yes.
What will be the location of that new point?
-3, -5.
-3, it's in quadrant 2. -3, comma,
Positive 5.
I mean, yeah.
2 people were talking, I didn't hear. -3, comma,
5.
5, right? -3, 5. The y value will stay the same. They're in the same height, isn't it? So the only thing changes for y-axis symmetry, the x value change. So for y-axis symmetry, we replace x with -x. What do I mean by that? Example. Check for y-axis symmetry. Okay? Suppose I tell you that f of x is equal to x squared plus 3. Now keep in mind, f of x means y, right? We're going to replace, for y-axis symmetry, we said this here. So every time you see an x, replace it with -x. So y is equal to -x squared plus 3. Do you follow what I'm doing? And if you take a negative quantity class and you square it, what happens to it?
It becomes positive.
Comes positive. So this is the same as if I write this. Do you agree?
Yeah.
Plus 3. Now, is this the same as what the original?
Mm-hmm.
Yes. So if the end product is the same as the original, then there is y-axis symmetry. If it wasn't, then all you can say there is no y-axis symmetry. That's all. Don't try to be whatever and try to justify what kind of asymmetries. The question was check for y-axis symmetry. That's all you have to do. They don't care about anything else. They just wanted to check for y-axis symmetry. Any questions?
No.
Okay. Now, let's see how many of you could use your street sense now. How about x-axis symmetry? So let's draw the little axis, and this is why you guys should get into the habit of drawing things to remember, because when you memorize, you don't remember them. So let's pick a point in quadrant 1. In quadrant 1, x is positive or negative, guys?
Positive.
Positive. How about the y value? Positive or negative?
Positive.
Positive. If you reflect this point along the x-axis, which quadrant would you expect that point to be in? If you reflect this dot in the x-axis, which
Negative.
quadrant would it be in?
Oh, quadrant
Four.
4.
Quadrant what?
4.
4. Yes, this will be the reflection somewhere over here, wouldn't it?
Yes.
Mm-hmm.
So if this is the original, this will be the reflection.
Mm-hmm.
And what would be the x value? Positive or negative?
Negative. Oh, sorry, positive.
All
Positive.
going to be positive and negative y.
Yeah.
And a negative y. Good.
Mm-hmm.
So what have you just confirmed? For x-axis symmetry, the y value will replace with negative y now. Right? Similar to what we did over here, right? The x value is replaced with,
Yeah.
for now pay attention, for y-axis symmetry, the x value is being replaced. For x-axis symmetry, the y value is being replaced. Do you follow?
Yeah, Professor.
Now, let's look at origin. So let's do the same little game we're doing, okay? Same little scenario. So let's pick a point over here. And we observe now in quadrant 1, this is x and that's y. Okay? Now, suppose there is a mirror in the origin. So suppose there is a mirror here. Where do you expect to see this dot? In which quadrant now?
3.
3. Somewhere over here. Do you agree with that? Yes? Now,
Yeah.
what x
Yeah.
value in quadrant 3? X value in quadrant 3, positive or negative?
X value is negative.
Negative.
And y value?
Negative.
Negative. So for origin symmetry, x must be replaced with negative x, x must be replaced with negative x, and y must also be replaced with negative y. Do you see the difference?
Yes.
So you have to do practice on this now, okay? I've showed you all of the little details. You just need to do practice now. Okay? So practice will be in homework, or if you go to WebAssign, guys, and you look at graphs, intercepts of a graph, we didn't touch that. You guys should look that up. Okay? And then they talk about symmetry. So an intercept is where the graph intersects the x-axis. We talked about it briefly, but not. Okay? So look through these videos and don't forget, right? I showed you guys today where videos are, and some of them are built in the notes too. Questions before we close off today's lesson?
Professor, for WebAssign, you gotta spend the $55, right?
Yes, the first few days are free. There's usually a grace period, but you'll need $55 to eventually get it.
And that's where we're basically putting all our work in, submitting it.
Guaranteed your homework will all be in WebAssign. I don't know if all of your exams will be in WebAssign, but guarantee your homework is on WebAssign.
All right. And as far as today's lecture, you're gonna put some of the things on Blackboard so we can review later, or what?
Well, there's always stuff on Blackboard, right?
And on WebAssign mostly. Got you.
No, the Blackboard course has been set up from day one. So you all have your class notes. But what I'm going to do, today is day 3. we met today.
Mm-hmm.
So what we'll do is probably add to the bottom of this today's lesson.
Oh, all right. I got you.
The thing is, not every day we're going to have Zoom. We're going to only have Zoom when there is a response for Zoom meetings. Right? Because this was supposed to be a fully online class where we have no meeting. So I would suggest that when you guys want meetings, you send me an email or an individual chat, and we're going to move on from here, because this class has 15 today, only 7. I'm not getting the full vibe of you guys that you want to meet.
Nah. I mean, personally, I don't mind meeting an hour or 2 with you at least a week. That's not a problem at all. I can't speak for everyone, but I didn't have a problem with today's lecture at all.
You know, funny enough is that when I sent out that that request yesterday morning, okay, so people immediately respond and say, why are we meeting? Okay, so I don't want to send out requests and then people are getting excited about it.